Good evening and welcome to Tinkering with Edkelar. Previously, I started to disassemble and clean a Fluke 5100B calibrator. Now, let's see how it went from there. The first PCB on the bench, the power supply regulator board. There's quite a few linear regulators on here, along with several fuses and two special circuits, the pop generator and what's referred to as an RTC or real-time clock generator. Not necessarily real-time, but it does use a 555 timer to make an approximate 60 Hz signal for timekeeping. I remove all the heat sinks for new thermal paste and replace all the electrolytic capacitors. I even managed to source the equivalent metal style ones. New thermal paste for the heat sinks. Oh, and I checked. The modifications to the transistors here add up with the schematic I have. So they seem to be revision upgrades. Also, replacing the electrolytics on the transformer board. I had to solder from above to avoid bending and possibly breaking the transformer wires. The next PCB is the one with the transformer. It is called Extended Range and High Voltage Board, so I assume that this is a candidate of something wrong. No electrolytics though, but two open relays that might need cleaning. cleaning the contacts of the open relays. Now to the wideband amplifier. Did I mention that there's quite a bit of shielding going on? This one also has an interesting way of getting the heat out from a set of transistors. Interesting. Exactly one leg of these transistors has a ferrite bead. If they say so. And this one is the wideband oscillator. Now, what's up with all that wideband thing? The base unit can produce AC from almost 0 to 1100 volts, and that with a frequency range between 50 Hz and 1 kHz, as well as 1 kHz to 20 kHz when we only go to 110 volts, or even 50 kHz for up to 19.9999 volts. That's quite a bit, but the wideband option adds to that. The voltage on the BNC output tops out at 3.1623 volts, but can go as low as 300 microvolts at a range from 10 Hz to 10 MHz. It's not hyper accurate, the frequency accuracy is listed as ±3%, but still good enough to check up on a scope display. The front panel deserves a good clean. I pop off the switch covers so I can get under the domes to clean the contact points. And I would not have thought to have a tube era wafer switch inside this thing, but here we are. Cleaning and lubricating. And here we go, cleaning the switch contacts. Some can be done as a batch at least. Pickled switches in alcohol. And on they go again. One of the caps has a crack in it. I'll try to glue it. The next PCB is the ranging PCB. Like about half of them, this one is sandwiched in two shielding plates, and even then there are coaxial cables on the inside. The upper shield is held in place with 4 additional screws. Why? These are also clamping down on a 1.0033 ohm resistor and provide heat sinking for that. A bank of socketed relays is held in place with a bit of foam, or at least it was foam in the 1980s. The binding posts are next. They are soldered to some assorted lengths of wire, and with all the precision stuff that is happening here, I want to disturb them as little as possible. But they turned out to be a bit suboptimal. What looked like gold plating at first turned out to be just brass. And also, one is a different style than the others. Meh. I'll see what my grab bag of binding posts has to offer. Much better. And another interesting module. This one carries a few heat-sinked transistors on a small add-on board. It is called the amplifier board. The power transistors on the amplifier board are fitted with a sill pad under them, but I can't resist to put in a bit of thermal paste, so I need to remove them. Whoever thought it was a good idea to use nylock nuts on TO3s, especially when the threads are just soldered in? Two of the posts came loose and I had to resolder them. Whoops, that seems to have gotten quite hot. And now, validating the power regulator. The manual says I need to short 2 grounds if I want to check it without the ranging board in place. So here I go. Adjusting the 3 trimmers for the 5-volt rails and validating the others. All good. And this concludes part 2. Join in next time for the conclusion. This bit is exactly underneath. Huh, dang it.